Okay, so my video explaining the surface area and the lateral area is apparently corrupted, so I'm just going to kind of review it here. The surface area is the whole area of the figure, okay? The lateral area means no bases. So for the cylinder, think about a can of soup. The surface area would be the can of soup, the label, and me making shapes. It'll be the can of soup. Sorry, I'm done. It'll be the can of soup, it'll be the label, and it'll be the top two parts of the can. The lateral area is just the label. So 2 pi r squared is the two circles. If we would do the total surface area, which is what we're doing here, 2 pi r squared plus 2 pi rh. Pi r squared is the area of one circle, and we've got two of them, which is where the 2 pi r squared comes from. Remember, if we unfold a cylinder, it looks like this. Kind of like a flattened Mickey Mouse. The 2 pi rh is the label. Now the 2 pi rh comes from that rectangle. The h is the width of the rectangle, that's the height of the cylinder. And then imagine the length, doesn't that length wrap around the circle? Yeah, it does, right? And so if that length wraps around the circle, what do we call the distance around the circle? Or, for lack of a better term, the perimeter of a circle. The bunny rabbit wants to play again. Sorry, it's been a long day. So the perimeter circle is 2 pi r. So I'm going to do 2 pi r, which is my length, times h, which is my width. So that's why the surface area formula of a cylinder is what it is. So to take away, so to do the total surface area, we do 2 pi radius, because this is the diameter, which is 14. Okay. So the diameter is 14, so the radius is 7. So I have 2 pi 7 squared plus 2 pi 7 times the height, which is 6. When you enter that into your calculator, you get 571.8. Now remember, if I wanted to just do the lateral area, I would chop out the bases. Okay, 2 pi rh only. Total, lateral. Or okay? This is a triangular prism. The prism is 2b plus ph, or not to be. I'm pretty funny. 2b is the two bases. Remember, a prism has two opposite congruent parallel bases. So you find the area of one base and you double it, and that's what you have here. Okay? Plus the perimeter of the base. Now, the perimeter of the base is the area of the base is the area of that triangle. Well, this happens to be a right triangle, and so the area of a triangle is base times height divided by 2. So I took the base of my triangle, which is 6, or you could say 8 is your base, times your height, which is 6, because that's where the right angle is, divided by 2, and so the area of one of those triangles is 24. So I have 2 times 24, two bases at 24 each. Then capital P is the perimeter of the base. Well, that's 6, that's 8, and because of this, you know that's 10, because you know that the bases are congruent. So 6 plus 8 plus 10 gives you 24 also for the perimeter. That doesn't always happen where these two are the same. In fact, it rarely does. So that's the perimeter of the base. H is the height, which is the distance between the bases, which is 8. You plug that into the calculator, you get 240 inches squared. And it's square inches because these are areas. So those are your two for those. Now, look at 67. That's a sphere. Spheres are pretty simple. The surface area of a sphere is 4 pi r squared. Okay? 4 pi radius squared. Be careful. It gives you 18, which is the diameter, so the radius is 9. 4 times pi times r squared is 1017.9 square centimeters. Now, on the back of the page, it was so much better when I did it the first time. If you look at number 71, that is a trapezoidal prism. Two trapezoidal bases, but these are asking for lateral area, not total surface area. So we're not talking about 2b plus pH, we're just talking about pH. So the perimeter of my trapezoid is 5, which is my base, 5 plus 5 plus 5.8 plus 8, which is 23.8. And then my height, which is the distance between my two bases, is 6.3. You multiply those together, you get 149.9 square centimeters. And the paper falls. I'm pretty quick. I love my reactions. I've got serious ninja skills. So now let's look at the cone. The total surface area of a cone is pi r squared plus pi rl, where L is the slant height. But I don't want the total surface area. I don't want that base in there. I don't want that circle, that pi r squared. I just want pi rl. The lateral area for a cone is pi rl only. You chop off the pi r squared. So I have pi times radius, which is 13, times my slant height, which is 30, and that's 1,225.2 units squared. Okay? And then my last lateral area here is I have, okay, sorry, I got distracted here. My last lateral area, perimeter of my pentagonal base, is 13 times plus 13 plus 13, 5 times, which is 65, and the height is 8. So my area is 520 square units, okay? So that's lateral and total surface area. And again, I apologize. I'm uploading a couple of these right now. I want to make sure that they're public, that they can be seen. All right, so let's look at some volumes. We're almost done here. So let's look at some volumes. I promise no more funny figures. For the volume here, this is a triangular prism. The volume of a prism is the area of the base times the height. That's the volume of a prism, okay? What is the base in this prism? The triangle. And you see how you've got that right angle? It's a right triangle. So what I need to do is find the area of that triangle, which is the same as the other one, and then multiply it by my height. Well, triangle is base times height divided by 2. Well, that's 6, so that means that's 6, because those are the same. So 8 times 6 divided by 2 is 24. So the area of my base is 24, and how tall is it? 12. So we're going to do 24 times 12, and we're going to get 288. And this is cubic centimeters, because we're now dealing in 3 dimensions with volume. All right. Now, let's look at the next one, which is a pyramid. Okay, this is a pyramid. Now, we just dealt with regular pyramids, okay? We just dealt with regular pyramids. Now, the regular pyramid should be, the non-regular pyramid, the volume is the same, but the surface area is where you can get kind of mixed up. But the volume formula is the same. What's the volume formula for a pyramid? Okay, it's actually 1/3 BH. Okay, H is different than L, remember, it's not slant height. So the volume is 1/3 the area of the base. What shape is my base here? It's a rectangle. It's a 39 by 15 rectangle. So I'm going to do 39 times 15, and that's going to be 585. That's the area of my rectangle. And then how tall is this guy? 16. So I'm going to do 585, which is what I already have. 585 times 16 divided by 3, and the volume is 3,120 meters cubed. Okay. Now let's do the last one over here. That's a half a sphere. Okay. Well, what's a full sphere? A full sphere is 4/3 pi r cubed. So what we're going to do is find the full sphere and divide it in half. So the volume is 4/3 times pi times 7 cubed. Okay, so we're going to do 4/3 times pi times 7 cubed. Okay, now that would be the whole sphere, but I don't want the whole sphere. I just want half, so I'm going to divide that in half. So that'll be 718.4 cubic feet. Okay, so that's how you find those volumes. Now we're almost done, guys. Hang in there with me. Hang in there. The end is near. Ignore me. I'm just saying stuff. Okay, So I'm going to find the volume of these guys down at the bottom that we kind of touched on in what is that thing we do every day? Oh, class. So we have here these composite figures. Remember we talked about composites? So these are composites. This guy is going to be a pyramid plus a cube, because we're looking at volume. So I'm going to find the volume of the pyramid. The pyramid, remember, volume is 1/3 BH. And the volume of a cube is capital BH. Okay? But those are different B's now. Well, they're actually going to be the same because it's the same dimensions. So I have 1/3. What's the area of the base? Well, it's the same base here, right? It's a 12 by 12 square. So 144. And how tall is it? What's the height? 18. And again, that's regular height, not slant height. So now let's add on the cube. The cube, the area of the base is also going to be 144, and the cube is 12 high. Okay? Okay? And so just so you can see, there's the pyramid portion, there's the red portion, and then here is the green portion. So I'm going to add red and green together because we like Christmas, and those are Christmas colors, and nobody really cares whether they're Christmas colors. So I'm going to do 1/3 times 144 times 18 plus 144 times 12. So the total volume of this guy is 2,592 cubic centimeters. Okay, now let's do this one over here. Okay, let's do this guy over here. This one, I have a cone. And I have a cylinder. Let's use purple because I feel all purpley right now. We have a cone and we have a cylinder. Okay, so I want to find the volume total. So it's going to be cone plus cylinder. So let's look at the volume formulas. The volume of a cone is like a pyramid. It's 1/3 BH. Okay, 1/3 BH, which is the area of the base is going to be pi r squared. So it's 1/3 pi r squared h. Okay, plus we're going to do the area of the cylinder, and that is just pi r squared h. Okay, cone plus cylinder. So for the cone, it's 1/3. What's the area of the base of the cone? Well, it's a circle with a radius of 40. So pi 40 squared. And then how tall is the cone? Well, if this is 50 and this is 80, that means the height of the cone is 30. Okay, plus, boy, we're running out of space here. Pi times, again, the radius is 40, 40 squared, times the height of the cylinder, which is 50. I know that's kind of hard to see because I ran out of room. So again, 1/3. Oh my goodness, sorry. I want to make sure I'm doing this right. 1 divided by 3. Okay, so 1/3 pi times 40 squared times 30 plus pi times 40 squared times 50. And we get a massively large number for the volume here. We get 301,592.9, and there's no units there, so it's units cubed. And I'm going to verify just to make sure that we entered it correctly. So we've got 40 squared times pi divided by 3 plus 40 squared times 50 times pi. And we get something a little bit different. So let me make sure that I entered this correctly. We have 1/3 BH, so we have 40 squared. We do 1 divided, oops, let me enter it this way. Let me try it this way. 1 divided by 3 times pi times 40 squared times 30 plus 40 squared times 50 times pi. Yep, 301,592.9. We're correct. Okay, and that's it. Now this other one here, sorry, I'm just a little tired. This last one here, we have a cylinder cut out of a prism. So this is you're gonna find the volume of the prism, and you're gonna subtract the area of the cylinder that's been cut out. The volume, I'm sorry. So what's the volume of a prism? BH, and then we're gonna subtract the volume of a cylinder, which is pi r squared h. So for the volume is going to be the area of the base, which is a square, 8 times 8, 64, times the height, which is 8 because it's a cube, minus, that's going to be the full area before we subtract the cylinder, pi times, what's the radius of the cylinder going to be if the whole thing's 8? 4. Pi r squared times 8. Okay, so we have 64 times 8. That is the volume of the cube. Now I'm going to subtract the volume of the cylinder. Okay, you see that? Well, obviously you can't because I don't have it on the computer. There we go. And so I get 109.9, and that is going to be my volume, and that is feet cubed. So there we go. There's the rest of the review.